Morning. I'm here to present a seminar on sequential circuits, foundation of a digital memory. So here is the introduction about the sequential circuits. Sequential circuits are one of the most foundational building blocks of digital electronics. Unlike combinational circuits, whose output depends on only on the present inputs, sequential circuit depends only on both present input and past input or history. In other words, they have memory. This memory is achieved through storage elements like flip-flops and latches, which store binary information. So combinational circuits output current inputs, and the sequential circuits output is current input plus past output. So here is some examples I want to share. In a traffic signal controller, the next stage, next state of light depends only on the current sensor input, but also on what the previous state was. Similarly, a digital clock. So a digital clock or counter remembers past values. So sequential circuits are crucial for devices that requires timing, control, and memory like registers, counters, timers, and microprocessors. Okay. Okay. Um, and the introduction was this. We can move to next slide. Flip-flops. And the topic is about the flip-flops. So flip-flop is the basic memory element of sequential circuits. So it can store one bit of the binary data, either 0 or 1. So flip-flops are bistable devices. Memories, they have two stable sets, set or a reset. So in these two states, the flip-flops can work. Next, they change stable only at specific times. So usually controlled by clock signal, which synchronize operations in digital systems. So main type of flip-flops. So we are mainly used some types of flip-flops. For example, SR, this flip-flop is known as a set reset flip-flop. So one of them is SR flip-flop and JK, D flip-flop and T flip-flop. D flip-flop means simply data or a delay flip-flop. So T flip-flop means toggle flip-flop. So the flip-flops are the basic elements. So here is the examples. The four examples are SR, JK, T, and D. So we can move to the next slide. Classifications of sequential circuits. So sequential circuits are classified mainly into two types. So one is the synchronous sequential circuits, and another one is the synchronous sequential circuit. So the synchronous sequential circuits, that the change in the state occurs only at discrete intervals controlled by a clock pulse. So all flip-flops receive the clock signal simultaneously. For example, digital counter, register, etc. So clocked operations state changes occurs only at discrete time intervals, as we said. So timing controls. All memory elements are controlled by same clock pulse, ensuring a synchronized transition. So here we are using only mm, uh, one clock pulse applying to all flip-flops at once, and the clock pulse can active once in a state. So design advantage. So there are the some advantages. So first one is easier to design or debug and predict behavior due to controlled timings. So we can talk about asynchronous sequential circuits. Asynchronous sequential circuits. There is no common clock to this sequential circuits. The state changes occur immediately when input changes. So these can operate without a synchronous clock pulse. As we said in the previous synchronous circuits, there is no any similar or mm, same clock pulse to each flip-flop. So this can operate without synchronous clock pulse. So it's faster but more prone to hazard or glitches. So there is a timing issue. A relay sorry for the distance. So timing issue rely on the propagation delay, the gates making them susceptible to hazard or race condition. So these race condition can be these race condition can be overcome through the uh, some other flip-flops or some latches. So there is an application for this user where speed in critical but are significantly more complex to design and verify. So examples, asynchronous control systems. So synchronous circuits are performed in most modern, most modern system due to predictable timing and easier design. So let's talk about some flip-flops. SR and JK flip-flops. As we said, SR set reset flip-flop and JK flip-flop. So let's talk about the first one, SR flip-flop. SR flip-flop set or reset flip-flop has two inputs. As well, we know set and reset. The operations, if S equal to 1 and 0 equal to, sorry, R equal to 0, the output set to be 1. So, and the S equal to 0 and R equal to 1, the output sets to 0. So S0 and R also 0, no change in condition. So previous state retained. So S1 and R is 1, no change occur. So it considered as invalid state. Because of the interval conditions, the SR flip-flop is not widely used in particular circuits. As previously said, S equal to 1, R equal to 0, output equal to 1. So this said to be set condition. And S equal to 0 and R equal to 1, the output is 0. This said to be reset condition. So with reset and reset, it can call as a sub flip-flop. So JK flip-flop. So JK flip-flop in previous SR flip-flop, the race on invalid condition can be overcome by the JK flip-flop. To overcome SR flip-flop's invalid condition, we use JK flip-flops. It has two inputs, J and K, operated as follow. So first of all, if J equal to 0 and K equal to 0, the output or the next state, this output can be called as next state. So this next state will be the no change condition. So whenever J is 0 and K is 1, the output is reset. It means zero condition. So whenever the j is 1 and 0 equal, sorry, k equal to 0, this set to be a set condition. Set condition means 1. So whenever the both inputs are in a high condition, it means s equal to 1 and k, sorry, j equal to 1 and k equal to 1, the toggle state will occur. Complement previous state. It also called as complement previous state. This means when both inputs are 1, the output switches or toggles, making the JK flip-flops versatile and widely used. Okay, here, this is the information about the SR and the JK flip-flops. Next, we can move to D flip-flop. D flip-flop means okay. D and T flip-flop. So D flip-flop means data or delay flip-flop. So T flip-flop means toggle flip-flop. So D flip-flop has only one input called as a D operation. Let's move on to this operation. Output Q follows the input D on the next clock pulse. In short, Q equal to D as a set or reset condition. This eliminates ambiguity, making it the most commonly used flip-flop in registers and memory devices. Used in these are used in a data storage, so shift registers and the memory elements also. The output Q follows the input D on the two clock edge, acts as a simple delay element. So we can move to the toggle flip-flop. It means T flip-flop simply. So these derived from JK flip-flop by connecting J and K together as a single input T. So if T is equal to 0, the output flip-flop on the clock edge, if T equal to 0, the state holds. So the major key applications are binary counters, frequency division circuits, where output frequency is half the input clock frequency. So whenever the t is equal to 0, the no change condition will occur. Whenever the t equal to 1, toggle output changes state. Toggle state means output frequently changing state. This is known as toggle state. When t equal to 1, the state will occur. So these T flip-flops are used in counters, dividers because of its toggle nature. Okay. Next, we can move on to the next topic, race around condition. This race around condition occurs in JK flip-flops when both J equal to 1 and the K equal to 1, while the clock pulse remains high for too long. During this period, the output keeps toggling continuously, leading to unpredictable results. The reason is the output keeps feeding back to the input while the clock is high. So here, to overcome this, there is some solutions to overcome these race around conditions. So we can use the edge trigger flip-flop or master slave flip-flop, which uses two flip-flops connected in series. So one active on clock high, the other one clock low to prevent multiple toggles. So triggering methods so, trigger when both we said J and K are high.